everyone, I'm Tomasz. I'm a senior Scala developer, and today with me we have Krzysztof Romanowski, who is the head of Scala and tooling at Virtus Lab. Hi, Krzysztof.
Hello.
Virtus Lab, with its 12-year experience, is a strong partner in software development and has a key knowledge in various areas such as custom software solutions and development efficiency environments. The latter, in case you don't know, is all the things that can make developers productive. This is why we gathered here today, to share our knowledge with you, and I am happy that you all were able to join today's webinar. The name of the webinar is Productive Developer Environments, 3 Essential Features. Stick around for the Q&A at the end of the webinar, where we will try to answer all your questions. You can write those questions on the Q&A chat, and if any questions pop up after the webinar, you can reach us directly on LinkedIn. So, with no further ado, Krzysztof, could you present to our viewers what's on for today?
Hello, everyone. Glad to see you all. And my name is Krzysztof, as Tomek has introduced me. And today I want to focus on developer environments, what that thing means, and the 3 essential features that is required to make those environments productive. So, moving on. First one, you just can build software just by piling up engineers. Even the best engineers, without tools, without processes, without good practices, it will just not going to work. So you need some kind of suite of tools, you need environment, developer environment, in order to build software efficiently. On the other hand, you don't really want that this environment is basically pile of hacks glued together with duct tape. So I hope that most of the developers doesn't need to actually deal with these hacks on a daily basis. And this presentation and this webinar is mainly focused on raising the awareness why people should care about the environment where the developer live, and some guides how to make them better. So what makes up a developer environment? I could just list the things, but rather I want to take you into like short journey when we go through the actual case. So there was people actually come from one of the projects to us and they ask for a help. And the problem was sort of common. They struggle with their tests. They were failing on multiple strange reasons. They were not working the same in different contexts. They would take ages for unknown reasons. And they just ask for our help. And we will see different parts of the environment with us like going through debugging the problems that we see. So when you ask a developer, okay, please show me what tests are failing, how they work, the first thing nowadays, in most cases, would be an IDE. So developer will just start up an IDE, show up a piece of code, and start to like showing up the text. And this was exactly the case. And the first problem actually appears pretty much instantly. There was some problems with running the tests because some of the tests they were not able to run properly in the IDE. Some failed in different manners than what they failed on the CI. But that constitutes the first sphere, the first building block of developer environments that most of developers spend most of the time. It's IDE. It's not surprise because IDE stands for Integrated Developer Environment, and the idea behind them is actually just to provide this environment. However, I never see a developer environment that consists just of IDE. There is always something around it. So yeah, so let's move on with our quest to find out what's going on with the tests. And then we see the build tools. So it's basically all the things that drive the compilation, running of the tests, and the releases of most of the software out there. And here the example like there was like a bit better than an IDE, but still some tests failed. Some tests failed differently in the CI, and there was like test takes ages to start, or in some cases they were not able to start single test, for example, to debug it. We of course go through and try to tweak up and fix some of the problems, but that's the second ingredient in our developer environment. That is a build tool. Then we figure out further down with the tests, and we figure out why some of the tests behave differently. And it's all about how the tests were set up and how the environment, like the local setup, how it was done on the CI and on the machine, on the developer machine. On the CI, it's kind of built into the CI definitions. On local machine, developer needs to do it by himself or herself. And what that local setup consists of. So simplest thing is few environment variables in the terminal that starts the build tool, or what kind of applications needs to be installed in what versions, what kind of services needs to run, like a database or maybe a Kafka or whatever for tests to work. And all of this, all the things that the developer needs to do in order to get tests running, get ID starts up, and to work on the project, it's what I call the local setup, and it's the third ingredients in our developer environment. But that's not end, because then when we see some changes, we push it to the so the code can be reviewed. So we have version control systems, there we have CI tools, there we have the task trackers, all of these external services, external to your machine in most cases, the developer needs to operate and needs to work with. And in this case, we actually find some problems. For example, the tests were green or failed in the case that we expect them to be, but they actually were really slow, painfully slow. And we dig deeper into that case to see what was wrong with those. And we stumble across another, not the last, but another ingredients in the developer environments, the kind of underlying infrastructure underneath those services, where in this case there was a problem because the Docker registry was not flexible enough for the needs of that project. So they need to start up every Docker image needed for any of the tests every time they run any test. I mean, there was something fishy there. I don't want to go into details, but it shows how infrastructure around it, so Kubernetes cluster, bare metals in some cases, influence developer environment. And we can go and add more spheres, more scopes, we can add company policies, culture. Then we are all human. Nobody still their AI is still not taken over programming. So biology comes in, physics. I mean, we need to stop that at one point. And for the sake of this presentation, we will focus on this three. So basically IDE, build tool, and local setup. And there will be some influences from the external services, but this is that part of developer environment is where developers spend, I don't know, half of the time, maybe a bit less, maybe a bit more, depending on the project. But that's where most of the code is actually is being created, where all the bugs are introduced outside of the bugs in the design. But that's a different story. And of course, there's many problems and many things that we can also analyze with this next spheres of developer environments, how to set up a code review policies to make no bottlenecks. This is a problem in many projects. How to make CI efficient, how to make your version control run smoothly, how to manage issues. I'm not going to dwell into that because all of that problem is kind of probably a webinar itself. I will just focus on these three. So how to make developer, and for this rest of this presentation, whenever I'm in developer environment, I mean these three things. Whenever I'm in the setup, I mean set up all this, all these programs and build tool and IDE and the configuration between those. So with that, I think we can get to the one of these three essential features I mentioned. And the first essential feature of developer environment that I just described is the ease of setup. So why it's so important? And why I call it the ease of setup? Because for me, the setup is not easy if it's not stable, if it's not reproducible, so it should work in all cases. And only if those two things are met, then we can actually say that if the setup is easy or not. So it's not about how many manual steps you need to do. That's the kind of the last measure that you need to apply. Because if the setup is unstable, so you do the steps and you don't end up in the stable setup, it means it's not easy because you need to remember and know and being able to diagnose all the problems. So that is why that's what I mean by the ease of setup and why it's so important. So here you can see a tree runs on the same test. I made it flaky just for the presentation or just for the stock, so it's apparently problematic. So basically, I measure how many environment variables is in the local environment, which makes no sense. But like you would expect, I get three different answers in the build from the build tool in the IDE and when I'm running on the CI. And did I run a different code? No, I run the same code, but the environment and the setup and how the things are run matters. And imagine that the case of the problem here is obvious. But if you, for example, need to debug a race condition on some test using message queues or something, and then you are not aware that it behaves differently depending when they run, you might actually go through and solve the different problem, which is ultimate waste of time. So is developer doing that on purpose? Like the setup in the build tool or in the CI or in the IDE is different? In most cases, no. There are some rare cases where, like, for example, some shortcuts are needed on the local development because setup of, I don't know, all the processes take an hour. But in most cases, no. This is basically something that I think should be eliminated. So what happens when this setup is not easy and when this developer environment and the setup is not productive? So let me focus on the Google case. So a lot of developers from Google, when they leave Google, they actually see the world that is completely different. They see different tools and they miss the tool and stuff so much, mainly because they do not feel productive, mainly because they are not productive as they were at Google to some extent. So there is even blog posts and talks for how to make the environment in your company sort of similar to what Google has. And yeah, you might say, okay, so everybody should copy what Google does and everybody will be golden. Not so much, because the environment is not just, there is no one single good environment for everybody. The environment needs to be an answer to all this kind of external things, like what technology is being used, what is the release module, how the team works, is the team remote, local, what kind of tools, what is the release procedures, what is the company policies. There's like, what is the focus on the project? Like, should we care about, like, really we should care about security and the validity of the results that we produce, but or do we care about the just producing code quickly? So, and as an illustration, we at some point were working with Gerrit. So Gerrit is a tool designed by Google and apparently loved there, but we're using it completely out in the different context. And developers that were on that project said like the project was okay, but the Gerrit was terrible. Basically, there's no way. There's like it's not working like that. Just like take it environment, the tools from one environment, just copy their way of thinking to another, and it will work. And the next example of this really problematic environment where it's not productive, it's when we were working for one of the clients, and then there were like all the problems. There was a lot of problems with environment, and basically we have this ticket queues, like support tickets that they need to open whenever they stumble across the problem, and we basically were flooded on this. But we take some measure, we actually make it much better, did a really big release, and actually the queues on our side in terms of tickets ended because the environment was finally stable and productive. But then something completely unexpected happened because the team, like it's like, let's say the next to us that was focused on core parts of the platform itself and the core library, they were actually flooded with tickets. And when we analyzed what happened, it basically was that developers were finally productive enough to face all of the problems with the platform because they were producing so much code, and the main blocker for their efficiency was not longer the tooling, but the platform that they were dealing with. And of course, other measurements that we took for stuff like time for when somebody just start working on the issue to the first successful run, or time to this kind of smallest loop like test code compile test loop. All of that improved, but it was mostly visible with this shift of the blame and problems onto the next team. And this for me, this is the best example, like how much progress and how much resources can be wasted when the environment is not productive, it's not stable. What is more, the ease of setup and the stability of setup and general the quality of your product and the developer environment might also affect the talent retention, might also affect, of course, satisfaction in your team. And I think it might also affect the diversity. Why is that? Because when developer environment is not approachable, it's not stable, it fails. You need to have a lot of knowledge outside of what is really needed for the project to thrive. Like if you have, I don't know, a web developer that is building the new front end for your application and the application cannot start that it wants to test and play with because you need specific skills to set up a database for test an application to start. And every time there is some change, that person needs to go to ask some other team for help. This is really like, confused. This is really like, frustrating for people. And this leads to burnout. And I saw teams with the bad developer environments when the team retention was like terrible. And what is more, there's often this kind of loop. I call it like hacker culture loop. So basically, you have a developer environment that burns out people that are not really deeply technical, but not technical, the technical in this kind of non-essential skills for the project at hand. And they're leaving the team. So there's so in action with the hacker culture. So people like finding and lying to play with this kind of strange tools are sort of promoted because only they can be productive in the team. And when there is a decision to actually should we make the environment more approachable easier, often it's like, no, let's pick this new tool because it's like in some case when you know right how to type this 5 magical command, then you will get it much better. And the loop continues. So developer getting less approachable, the environment getting less approachable, more and more people leave the team, and you lose, and the team is losing often the crucial skills because the technical mastery is not the only thing needed for the project to succeed. You need to think about like how communication, how exchange of the knowledge, or basically interaction between people goes. That's important. You also need to have a business focus in mind, and this like and just because of setup, you will start losing this kind of using this valuable people from your team. And it also often that you company struggles for like to hire diverse set of developers, and often like this kind of not stable environment is really stressful situation, especially for people that are actually new or are getting into there or there. And if you add another level of stress beside being from underrepresented group, that might actually be the thing that will break the rod. Not the reason that somebody resigned, but it might be one of these 5 reasons that somebody resigned from your team. So that's I think is also important to have in mind. And how to improve this ease of setup, so the stability, the quality of your setup, so how developers are able to be productive with your setup. So there is these 4 things I strongly recommend to focus on. So first one, there should be a single source of truth. If there is 2 ways how to set up stuff or 2 ways how to run stuff, maintaining both so they yield the same result is really hard. In most cases, I would argue that the best single source of truth for everything is a build tool. And I really like this a bit change in, for example, how IntelliJ approaches the build tools. Because previously the build tools was like mainly to set up the IntelliJ so IntelliJ can run stuff on its own. But now there's more and more cases where it's actually just a proxy for a build tool. And especially for more complicated stuff, it's really hard to replicate all that is encoded in the build tool on the IDE. So that's kind of good way to move forward. Then it's unified. So if you have different ways to set up an environment for CI and your local machines, you will need to at least be aware of the problems. If not being able to get the different results, or even not being able to debug the things on the CI. Then there's this obvious things to automate. If you need to do manual steps, like we are not really good at doing that in the long run, especially under stress, or sometimes you just might forget to check every time you, for example, switch to a new branch, you should check if the readme, if the setup changes. And as the problems that results from that are not obvious, they're like some small change in behavior that was picked and is needed for something to work correctly, then it is another a source of waste of your time. And the last thing is that we will never run out of this kind of manual stuff, or out of the things that that are not really worth to encode in build or any other place as a single source of truth for you. But so if there are things like that, the requirements outside of those should be explicit and complete, so everybody knows what's going on and can check that list. And I think the goal, long run goal, should be actually to get that list to have 1 or even 0 positions. Because I remember I was working in the environment, I was creating environments when you got a vanilla computer with basic tools installed that comes from OS, and that was enough to set up the environment. Basically, you just need to copy one command into the command line, and everything else was set up through there. Of course, that's the ideal state, but it's often you need a lot of investments to get into there. So if the list is like, I don't know, you need an IDE to be installed in the build tool and maybe something else, that's still okay. But if you need to, pay attention that between the branches you need to update your Python because that script will not work even though all of your code is written in Java, that's probably not a good requirement that you should have on that list. So what is how we can improve this setup incrementally? So the algorithm I suggest, it's really it's a really top level of look, because those problems are usually different from a project to project. So I would be more than happy to actually take a look at your problems, and maybe we can talk and find more fine-tuned approach in your case. But generally, the first thing is just you need to list your problems if they're set up. Then you will need to rank them in the kind of 2 categories. So how often it happens and how much impact it has on the developer and the environment. And you might take it literally, but I think there's like a second. You need to pay a bit different attention to both those how you rank things on. So because something that you need to do manually, it might happen every day in the morning. But if it's always every day in the morning and you get quite plain error message that you just need to do it, or if you need to change something every month, I don't know, say some switch or whatever, change some requirements that there's in the bound included there. That's probably not a big deal, because you can, for example, create an event for everybody in the office to do it or something. So if something happens on often but is predictable and it's easy, and it's easy to see that you need to do it, it's not that big of a problem. The most dangerous cases is, for example, when you have a specification in your database in the code, and the requirements that every time you check out given code, you need to actually throw your database and apply this new set of schema in your database. And this takes some time. So the developer probably would just skip it. And if it changes, it might change it at any point, and it's costly, and you have no notion from the outside that you need to do it because some tests might just fail on that. That's probably the thing that scores high in the how often it happens. And the same with impact, because you may imagine that you might have a test that requires Apache server to be installed to work, not kind of requirements that I can live with. And if you don't have an Apache server installed, it will just fail with a message, okay, there is no Apache being installed, or there is no Apache on the path. And you might say, okay, this affects half of our test, so it has huge impact. I would argue that it hasn't that much of an impact, because you just need to install Apache, and the message is almost obvious. So it's like probably the message could be improved, but on the other hand, if there is 10% of your test that requires that let's say your Spark cluster that you run them off contains more than 5 nodes, and you just set up a 3-node cluster, and then it failed with some kind of race condition issues, that's a huge impact, because it's not like a lot of tests was failed, but the amount of time for a developer in order to find out what causes the problem is huge. Because in most cases, those developers will take a look at what is the problem with my code, rather than looking what's the problem with my setup. So once we have this list, then I suggest to pick like 3 or 4 or 5 or 6, depending on how many resources you have, and fix not like the most important one, but 2 or 1 or maybe more that are the easiest to fix. Because this making setup easy is something that is pretty much an endless task. And I would strongly suggest not to spend way too much resources on that. And especially when you see gains, and you start to do things smartly, you will learn on the way how to do what works or not. Then you will be much better, and maybe you will approach the problem from the right angles. And then repeat until you are happy, or maybe do it constantly. So your developers get better and better environment every time they work, every day they come to work. And I said it before, but I want to really stress: do not overcomplicate. So here you have two different ways, two different design for solar tracker. The one on the right is, for photodiode, some two servos and the Arduino and some resistors. It's not that complicated, but if you want to know just roughly when the sun, or what is the direction of the sun, you can basically use like two solar panels and four cables and one motor. So, and I would argue that what you need into making up your setup faster is the design on the left. So basically the as simple as can be. In the case of the Apache server, so let's say you decide that there's a big blocker for us. So for some reason installing Apache might be not like it's happened in many cases and affects a lot of developers, and we want to fix that. So like we can try, use the headless Apache to be installed. We can rewrite the test not to use external application, but rather use some kind of embedded server from the JVM. Options are there is multiple options, or we can just detect that message in the logs and print another one that just please install Apache server, and there is a guide how to do it. And for me, the latter solution is simple and can be done within an hour or two and can make your developer much happier. And the return of investment from this kind of thing is much bigger. And so now we're getting to the second feature of the developer environment. That is roughly reproducibility. And what is reproducibility? So from scientific point of view, that's the kind of one of the criteria for an experiment to actually be, so they can be verified. So the same experiment, the same analysis, the same study done in the similar condition should have high degree of reproducibility in terms of the results. With the software environment, so what affects to us, we want to follow even stricter reproducibility rule. So basically, every time we build or do something, the same inputs, the output should be exactly the same, up to the every single bit. I mean, or for example, when we compile Java code, the results should be the same up to the modification date in the jar. Those kind of things. And it's sort of similar. That's like basically one of the principles of the functional programming. So let me show you an example when the reproducible setup and the results are not reproducible. This ugly screenshot, I'm really sorry for the quality of it, but I'm not using Eclipse for ages. I'm not even sure if it will work with these kind of old things and if it hasn't changed. But that's sort of the representation of what we faced 8 years ago when we were like working with Scala in Eclipse. And basically, there's like three different icons there, like this kind of X one and this kind of big circle with this white X. And both of them actually represent an error in the code. And the funny thing is that depending on how you get there, like what was the cycle of compilation and running stuff, you might get two of those kinds of the error. One might be sticky. So depending how you set up your IDE on what point, you might get completely different error. And what is even worse, because of this, there was like a lot of flakiness and other things there. Often, and especially for the newcomer developers, and back then there was most of the Scala developers was newcomers because it was a new technology on the block. People were fixing problems that they were not actual problems, but it was like the leftover from previous compilations. And this I think this is one of the key contributors to this notion that Scala has a terrible tooling. And it all boils down that the setup and the compilation was not reproducible. So compiling the same piece of code, depending what you did before, produces different results. And that's crucial for our setup. When you have an environment, regardless of what you did before, it should work. So if you change a branch and if you follow this, cleanup or even best, it's like picked automatically, it should reflect what things is in that commit. So developer at best shouldn't think if they're likely to do some, clean everything or set up correctly, because they will get different results. And there are some shortcuts for reproducible setups I want to share here, because later on I will show that the reproducibility might not be that easy to get. But currently we are living at this, I think, a pivotal moment for this environment, because I said at the beginning that we will have this local environment. And I think now is the time where it's actually all shifting into the cloud, into the Dockerized containers like Gitpod, and both like the main IDEs that I work with, so VS Code and IntelliJ, the four family from the IDEs from JetBrains, goes into remote IDEs. And why it's a pivotal change for me? Because then you have only single environment that you care and you can build, and you can even build it directly for each commit. If this requires that you can pre-compile stuff there. So there is a lot of options, and that's the kind of shortcut for the reproducible build. Because with the single way how you developer setup, let's say it's a Docker image run on some kind of container somewhere, then you cut a lot of variables in terms of what affects build, and that's a shortcut. Because I tried to, for example, make a simple build of the huge code base to behave the same in Windows and Linux, and after a year, I think I failed. Just because how hard it might be in some cases, and remote IDs and being able to just have one single setup for everybody, regardless of whatever they want to have on their local machine, it's super promising in my opinion. So when the builds are not reproducible, I shared the case of the Scala, but another story is where that we were working on the project, and the builds were like, it was a Scala build a long time ago, so you can imagine the problems that I showed was a common thing. And we fixed most of those problems. So builds start to become reproducible. So if you compile stuff, in 99% of cases, you get there to the same results regardless what you did. So the improvement was huge. And then I actually paired with some developers to see how they struggle with the tooling to actually improve their it even better. And I noticed a pattern. So basically, developers that remembers the time, how the environment works before the change, they didn't trust the results. And every time they see a compilation error that was not obvious, they clean compile everything that takes half an hour. And developers that do not remember that, they actually start, like when they see a compilation problem, they start analyzing it and start to fixing it. And you can imagine how much time was wasted on this kind of old developers when they lose trust in their tooling, just because they were actually clean compiling stuff where they don't need to, just to realize that, oh, I need to fix that problem with this compilation. So, and that goes even further, because then if you have not reproducible builds and you ask for help somebody that, you are a junior developer and you need some help from someone more senior or experienced, and your developer is not reproducible, we often ends up with the case where what you get is like, oh, the problem is that because you haven't clean compiled this 5 hours ago. Oh. And you basically, it gets you into a state that before you ask for help, you do more and more and more, and you literally lose more and more time. So yeah, I see multiple occasions when developers actually, because the tooling were not friendly and approaching and not reproducible, so they get different results, they stop asking for help, which is a skill, especially in IT work from my experience, that need to be really like motivated people to ask for help, because people have too much tendency to stick on and to themselves and trying to solve their problem rather than to ask somebody that knows the solution. The problems can be fixed in 5 minutes. So reproducibility in terms of build is not as something that just like I'm the only one to recommend, but in most cases, it's recommended because of the security concerns. Now we probably, I hope, I mean, there was this case with SolarWind and basically a supply chain attack. So basically somebody affects the way how the software is built to introduce vulnerabilities. And reproducible builds, so basically comparing two different builds of the same code, up to bit, is one of the techniques to actually secure yourself from this kind of attacks. And that's why most people know security, reproducible builds. There is the whole page with some open source companies, open source projects that commit to some common goals. There's a few interesting things there. I suggest to go there. So that's actually something that you will get when you want to get your when you get bits reproducible. You not only get benefits in terms of like developers are not wasting times because they debug problems, or they're more willing to ask for help and just basically discuss or even collaborate in the same piece of code. And you also got security, but the thing that is for me is almost a game changer is sorry, the order is wrong, is the fact that you can cache and not compile again or not generate source stories of dependencies multiple times. That's actually a case study. It's like this this graph is taken from there's really nice benchmarking of the Bazel remote cache. Is basically able, so you just don't want to reuse the same you want to reach the same results of the of given task rather than do it again. And when you have reproducible build, you can completely do that because there's a guarantees, or like try to do everything that the results are the same. And as you can see on the right, when you come back to the old thing, the green bar is pretty much not there. So you can see, and in this case, there was like a gaining is like way over 1,000 seconds. So it's a huge gain. Of course, that's kind of a benchmark, so probably it's like made to be better. But we solved the problem with long compilation time for Scala exactly with aggressive caching. And we have like one solution was not really up that much reproducible because we assumed that the given commit will be compiled again to the same code. So if the commit was there, no local changes, we were able to apply a cache. And then we are able to get the results like, just a few times faster. And then there was like much more work and much more aggressive approach. So the caching was done on the level of single task, like compilation of this module, resolving dependencies for this piece of code. And we got another like few times improvement. So some things like went down from like 2 minutes to like 20 seconds. And that's huge, especially that if you take the order of magnitude of how much task it takes, you keep your developer more in the zone. So basically they are focused and they are solving, and they'll be like more willing to wait. Because if the developer, like let's say if build takes like 10 minutes, developer will most likely go to grab a coffee, start a conversation, come back in like 20, 15 minutes back when the code is compiled, and then he will need to remember, or she will need to remember what was the context of that given change that needs to be introduced. But don't get me wrong, full reproducibility, it's rewarding, but it's really hard. So why is that? Just because in our build tools, we often have this a lot of custom code written. And there are stuff when developers write this code, they often do not think about reproducibility. Like, okay, we got a map and we iterate over it. It's not a big deal. For reproducibility, it is, especially with a hash map, because things can change. And also, what makes even worse is that some compilers and some tools on dependency resolution is not reproducible by itself because developers do not put a lot of enough attention to that. So from experience, like getting there, it's hard. However, I think the gains often are really important. So you probably should not aim for making all and every bits of your build reproducible. So what I suggest to try to make reproducible, so setup. So there's always the same kind of tools and everything needed at hand, a build, and the release because of the security concerns mainly. And if we make some of the tests reproducible, there is a huge gain that can be gained for especially CI times. And when you are comfortable enough and confident enough to just basically skip some test that is being run on the CI. And that's the kind of beautiful thing about reproducibility, that it starts to pay off even in a small scale. So you don't need to be fully reproducible every place whenever you go, because I don't know, test report that you generate, should it be reproducible? Like in terms of like what is the order of nodes, or if there are some timestamps, maybe you are able to live with it. So then we come to the last aspect of last feature of developer environments, and that it needs to be tested. It needs to be maintained. So why you need to maintain your developer environment? And why it will change? Because there might be this temptation that I will build this like a castle out of ice, and it will stay in this perfect condition that right way. But there is always a change needed to be done. Security vulnerabilities like Log4Shell, and I'm sorry, but I keep bringing up IntelliJ because it's one of our best expertise. But in some version of IntelliJ, the Log4j was used, and even though it doesn't really affect the security on that cases, some companies were panicking and were like forcing developers to update their IntelliJ because of that. That sort of makes sense, but that is the change that we can break your like carefully crafted developer environments, like the M1s and 2 architecture from Apple. That's a kind of big change, and the gains that you might get out of that are like really big in some cases. So you want to get there, and that is why you need to be able to change your developer environment. And when you change stuff, the things will break. So testing is crucial, and this is the kind of example why it's crucial. That's the representation of the how an algorithm in one of the IDEs works with like import of the project. And it was well tested. The change was actually introduced back then, was actually good because it speeds up stuff as it turns out. You can see the red lines is a bit slower for where the tests were. However, our workspace was quite much bigger than what the test code covered. And there was some exponentiality in the algorithm there hidden. And in our case, it actually was 3 or 4 times slower. And it was like the change from 1 minute that developers should be kind of okay to wait into 5 or 6, or that was a lot of like on the edge. And since this is something that we actually train our developers so hard, so whenever they change a branch, update stuff, they need to regenerate, like so basically update the IDE with the changes from the build tool in order to actually work with them. So they call the code in code insight and stuff like that were up to date. Whenever they will introduce this kind of drop in performance, they will basically say, no, I just stopped doing that. And all of this kind of effort will go away. Luckily, we have a test, automated test for it. And so we pick it up. But testing of the developer environment is not an easy thing because you have so many moving parts there. Like writing a test for a build tool is hard. Writing a test for IDE is even harder. Writing a test for integration between build tool and IDE with specific setup, because this is what we are talking about. Those things are like not something that everyone can do in like an hour. And because, for example, the decisions that you need to make, your goal, you like critical path for you, so developers are able to run without the problem this set of tests in their IDE. So, and there is a question, like you want to write a scenario for that. Should you create a custom test that is basically for there, nobody will touch it just for the sake of the test, or should you use existing test from a code base? Both has pros and cons, and that's kind of one of the easiest design decisions that you need to make when you're designing your and test for your environment. And another thing that I would strongly argue for is that those tests needs to be automated, because if you do not automate your tests, if your testers will get the expertise that is needed to make your like IDE and picks up the things and know what to test manually, even with the good scenarios, those basically are like they need to be like have a lot of skills needed for developers. And in my opinion, often when the people actually get into the speed with that, they either need to have really good testers or really focused testers on that, and or who will struggle to have a good manual testing for this kind of problems, and you will be not able to run it as often as automated ones. And this, especially when you're working in a developer environment and introduce some changes, or even you run it as a part of a CI daily, then you are able to pick so much faster the problems with your tool. And what is more, you can introduce performance measurements. I will come to that back in a second. So what is the kind of survival guide for writing developer environment test? So actually, the first one adds a bit to the complexity, but I think it's really worth. So you should test the actual environment that you have, not some kind of mocked. I mean, you might have a test like this, but the test for the whole thing is really needed in order to be sure that, okay, there I counted and taken into account all of this kind of moving parts, all of these things that can break, and our developers will pick it up. Then, as I said, there's multiple moving parts, multiple scenarios that you can focus on, but there's two main things that you look for. So like the obvious and important things like compiling or running the test for a certain category. And other thing is like all of the things that in your stuff are not that are custom. So an example of that is like, should you test if your IDE show the right errors and right completions? Probably not, because their IDEs are well tested for that. Unless you have a custom plugin for your IDE to tweak that, then you probably should test that because it's a custom thing of yours, and the people that maintain your IDE build tool probably doesn't have a test for this piece. And I mentioned performance. You really want to measure the performance there. It will never be a benchmark. Like, I mean, this is way too much. Like, benchmarks are only good when they are stable, and there is no way that you will get your IDE and build tool environment to behave stably in the stable manner, like up to 1 or 2 or 5%. Like good setups is like around 20% difference between rounds, but it's enough so you can pick up a huge regressions like the one I showed earlier, and also you will be able to see some trends. And when you see that like every month we add 5% time to 5% to our compilation time, then probably you need to figure out that will give you a clue that you need to stop that trend at some point. And probably the most important thing is like you should really focus on the proper tools, and you should use the proper tools for that, because there's a lot of utilities there. And we created one for that's called IDE Probe for the testing of all this kind of IntelliJ and other JetBrains IDEs, designed exactly to test your full environment. And there are features like, what were like the most common problem when you really like to test your IDE, not in the headless mode, in the actual mode with like faked UI, was that in some cases there is this pop-up showing up that's blocking compilation. It's from version to version. Sometimes your scenarios that does not account that this might happen, especially with a fresh instance of your IDE. And you would debug that for ages, unless you get a tool like it's built into IDE Probe that take a screenshot of the thing that you test, and the thing is obvious. So yeah, that takes me to the end, and there are like 4 key takeaways I want to from this presentation. So first one is that developer environment is a key for satisfaction and productivity of the team, and mainly in the way that the bad developer environment can have that detrimental effect on talent retention, be a blocker for building successful, productive, and diverse team. Then you should have a single source of truth for your setup, and it should be automated and transparent to users. The reproducibility should be a part of the key aspects of your build. So like your setup, your build, and your release should be reproducible. And it will bring stability, security, and it might also improve performance if you invest in caching. And last thing is that you need automated tests to maintain your developer environment. So you should work on improving your developer environment. And now I will be happy to take any questions.
Thank you, Christoph, for all that information. I think a lot of that is pretty useful, and not many people are actually aware of the problems that development environment can cause. So let's go to the questions. Spoilers, I also asked some questions because it's a topic that's dear to my heart. And let's go through my first question. So my first question is, Are there any metrics that can help me measure how productive my developers are? So, when exactly should I know if my development environment is fine or when it's not? How to do that?
Yeah, so there are like few things that can be measured. For example, what is the average time from develop for like between changing the branch on the developer and up to when the time the code is compiled successfully, or general like also average time between this basic loop that developers works in, like what is the time between the edit and when the developer gets successful compilation or like error being reported, or what is the time from like when they start edit to get the first run of a test. But for these measures, you probably need to focus on like build some tooling to do that. A lot of the IDEs have built-in measurements for some key areas. Like, for example, IDE gives really good times for like indexing. So basically, the time when IDE is idle, and it might be idle. It's not that doesn't have full features, and most developers are not really productive when the developer is like when the IDE is not indexed. You can also look at the kind of more general measures, like for example, how many PRs are open, or what is the time from like PR being opened up to the PR being merged, or what's like the queue of the PRs. So many things, and it mainly depends what you can measure and how much you are willing to invest to actually build some tools to measure such things.
Okay. Thanks. And I have a second question. So let's see if I can just click this. Okay. So my second question is: should the maintenance of such a developer environment be owned by the developers on the team, or we need a dedicated team for that?
I mean, dedicated team is always like in most cases better. It might be more expensive, and this might be prohibitive to some smaller projects, because then there's like a clear focus on developer environment, and like big code bases has this like teams not only for just for developer environments, but I know that companies and huge monorepos have a team dedicated for IDE integration, for build tool, for CI, and for even for Git team in some cases. For smaller projects, probably like a half time of one developer that is like really eager to work on improving the environment might be enough. But if there is a team, that in most cases better.
Okay. Thank you. If there's any other questions, please ask. I don't see any right now. So remember that you can always send us the questions on LinkedIn. We'll try to answer, or Krzysztof is always happy to try and help out in all the tooling and the development environment areas. And since there's no more questions, I would want to thank you all for attending the webinar. It has been recorded. Actually, we're still recording. But if you want to rewatch the webinar, which I highly recommend to everyone because it's really a tough topic that not much people are dealing with, we will send you a link to that later. If you have any questions at all related to software engineering or what we do, spoiler alert, we do a lot of tooling and development environment. But feel free to contact us anytime via LinkedIn or anywhere you find suitable. Thank you all again, and goodbye.
Thank you. Bye.